Giovanni Barillari talks about why I still develop a synchronous web in the asyncIO era. Thank you, Giovanni.
Thank you. Okay, so hello everyone in this Sunday morning. First of all, I want to thank you all to be here, because I know after Saturday night it's not so easy to be ready at 9 o'clock. So thank you for being here. I'm Giovanni. I'm a physicist actually, but since 2012 I actually work a lot with web applications. I love open source, so feel free to search me on GitHub and see some projects I work on. And just before we start, I have to warn you about this talk, because it's quite subjective. This is why there's an I in the title. And I consider mainly database-driven applications when I talk about web development in this talk. So let's start. What is asynchronous I/O? It's actually a technique, an approach to achieve concurrency by changing the way how processes are managed during I/O requests. So basically, instead of following the system schedule provided by the kernel, you actually continue to run your process instead of waiting for I/O operations to be completed. And asynchronous I/O is mainly based on the concept of the event loop. The event loop is the most classic form to do asyncIO today, and is mainly based on the concept of callbacks. So you actually use callbacks that receive the I/O data when the request to the I/O layer has been completed. So mainly, development in asynchronous I/O is mainly based on callbacks. And the event loop, it's mainly something like this. So you have usually a single thread that actually runs on a stack of tasks to be run. So when you actually do some I/O, you're actually putting something on a queue, and the event loop is the one responsible to run your code when it should be run. This is mainly based on actually how the JavaScript event loop works, but things in Python are a bit complicated, but the scheme is okay also for Python. And why I say asyncIO era? Because mainly in the last years, we are seeing that the web development started to move on this sort of new stack, and everything started with JavaScript actually. Why JavaScript? Because JavaScript was initially designed to be the scripting language for browsers. So JavaScript itself as a language is structured to be asynchronous on everything. And this is clear to us because, I mean, browsers are mainly event machines, because they react to user input and do something. So this is why JavaScript was made to work on event loop. And then Node.js came to the light, and JavaScript became also a language to be used on the server side, on the backend side in web development. And the reason for its success was that it keeps the same logic you have on the front-end side, so the event loop, the synchronous way of writing your code. And yeah, it found a lot of front-end programmers that they already have this way of thinking. So yeah, it had a lot of success also on the back-end side. And yeah, because you know the ability to use the same code on the front-end side and on the back-end side was actually quite cool for a lot of programmers. So, but this peculiar thing changed the way asynchronous I/O is used, because non-blocking I/O was designed for all this situation when you have slow connection, have slow operation on the I/O side, so you cannot predict how much your code will take to run. But yeah, with Node.js, with JavaScript, it became the standard de facto way to do web applications. So instead of using it just on the slow I/O interconnections, we started using it on everything. And why that? Because we all hate threads. I mean, even if you take some academic courses, usually threads are something quite criticized in multi-threading programming, because multi-threading programming is something hard to follow. It's quite hard to predict how a multi-threaded software will behave, and also there's this conception about threads that they are quite expensive to create, to maintain in an application, and so with Node.js and with the new asynchronous stack, everything just became easier to do concurrent programming, and in the Python world specifically, threads are even more complicated, because there are some misconceptions about the global interpreter lock. I mean, every Python programmer sooner or later face the GIL, the global interpreter lock, and it's not so easy to understand what it does and what it doesn't on your code. And so also in Python, the asynchronous model with new libraries, with asyncIO module in the standard library, just avoided us to think about this when we do concurrency in our applications. And so since Python 3.3, we started to move from other stacks about asynchronous programming and concurrent programming, and we started to use these new features we had with asynchronous I/O, with the syncIO module. So today, asyncIO in Python is made mainly with futures and coroutines, and where a coroutine is actually a function, for example, that can actually faking return while still remembering its state. So when you actually do, for example, a yield from or an await inside a coroutine, actually the system stores the actual state of your function, and then when the I/O data is ready, the function will be actually resumed from the line you were waiting for I/O, and all the context will be preserved in your stack. And so with the syncIO, we can see that actually we are trying to move to this new stack almost everything regarding web applications. And okay, it can be a good idea, but actually when I started looking at the asyncIO, I just, started asking myself, okay, so what the pros and what the cons of moving to a new stack, moving to the asyncIO stack from the, let's say the old one, the synchronous one, the normal way we build web applications till today. And so to all the people that actually says me, oh, come on, let's move to asyncIO, I'm just saying, are you really sure? Because, okay, on the paper, we have two main pros about asyncIO. The one is actually you can enhance the throughput of your application, so the number of requests you actually can serve with your application will be much higher. This is because actually you're moving from code that is not, I mean, your code is not really asynchronous in the standard way you build applications, so it's not really concurrent. The concurrency in web applications, you usually do it with multiple processes that are actually serving your application. But with asyncIO, the throughput should be something to be much higher. And the other fact is that one pro can be that your code should be more explicit about I/O integration. So you actually will know easily where your application does I/O. So let's take these two pros and analyze them to see if there are any cons about these two facts. And the first thing I wanted to talk about is the throughput. Now, the throughput is something like, let's say, a myth. So, because on the paper, everything that can be compared to the old stack with the asynchronous way should be superior for concurrent performance in all the cases on the paper, because you're actually doing things instead of waiting. So on the paper, everything is cool. But my first question about your web application is, since we are talking about I/O, asynchronous I/O, are you sure your application is I/O bound? Because the definition of I/O bound, it's that condition where your application actually spends more time waiting for I/O data than processing it. And so the circumstances where your application will really benefit of the asynchronous I/O stack is the one where you're actually waiting more time, I don't know, for example, on the database data, than parsing them. And also, are you sure the actual bottleneck of your real-world application is the I/O? Because it's not a big news, but Python is slow. I mean, really slow, because if you actually think about databases and database-driven application, we have that there's this sort of common sense that the database is the slowest part of your application. But this is actually true on static languages, on compiled languages. So much faster languages compared to Python. I don't know, C, C++, even Java is more performant on compared to Python on, for example, parsing data on the database. Because if you actually analyze the stack when you select some records from the database, this is an image that splits the time used by PyMySQL, which is the library that you use to connect to MySQL databases with Python, and this is actually raw, so it's just use PyMySQL to send select from table, etc., etc. And you actually see that if you split the time used by PyMySQL, you actually see that the I/O with the database is actually a really small part. All the time, the majority of the time spent in your Python code is actually for parsing data from the database. So even if you can optimize the I/O with inside your application, you're actually optimizing a really small part of your code. And another news, but it's not really a big news, asyncIO is actually slow in the standard implementation in Python, because you actually, if you want to do concurrency using old stacks, for example, writing manually threads, you actually get that they are faster compared to the asyncIO stack. And these tests were made by the creator of SQL Alchemy, so I quite trust him. And but yeah, we had this company, Magic Stack, that actually made a library named UV Loop, which is a replacement of the standard event loop inside the asyncIO module in Python. And you actually see it's quite amazing, because with UV Loop, you're actually running asyncIO really fast in Python, because you can have, this is a test about TCP connections, and you have that it's comparable with the performance of Go language, which is really crazy. I mean, it's amazing. And, but there's a but, these are TCP connections. So it's just the, the network part. And web development is something more. So going back to databases, they also made an awesome library which is named asyncPG, which also performs in insertions, raw insertion of records on the database performs better than Go. So this is quite amazing too, but there's another but. It's actually written in Python, so you're actually quite cheating. I mean, it's not really Python. You're actually using C code to run better performance. And also, I can't use it because it's not compliant with the standard DB API of Python. So, okay, let's get to the real stack. I mean, building web application is something more than just opening up network connections, and also when we do some comparison, when we want to see if our application will perform better, we actually should ask ourselves, what are we really benchmarking? Because there's a real problem about benchmarks. And the first one doesn't have nothing to do with the asyncIO. It's a really old problem about benchmarks. And is that you actually cannot compare them. I mean, for example, let's take Falcon. You know Falcon is a web framework written in Python, and it's synchronous, it's not in asyncIO. But if I go to the Falcon website, I can see that on PyPy, I can have 10 times the requests I can serve compared to the standard Python interpreter, which is fucking crazy. But if I go to the Tech and Power website, which is a company that made some benchmarks, they run 3 or 4 rounds every year with a lot of frameworks, web frameworks. You can see that actually in their tests, the PyPy implementation in Falcon is slower. So which one is right? Should I use Falcon with the standard interpreters? Should I use it with PyPy? I don't know. So this is the first problem regarding benchmark. They are not really comparable. So you actually have to choose on who trust when you actually consider benchmarks. And we actually should stop looking just at numbers because, for example, for the asyncIO stack, if we see on the Sonic repository, Sonic is an asynchronous web framework written in Python, we can see that actually performs like two times the request you can do with Falcon. So it's, I mean, if you just look at numbers, you see, my God, it's amazing. I mean, I can write something in Sonic and just performs really better compared to Falcon, which is one of the fastest frameworks in Python. But actually, you should ask yourself what they benchmarked, because, sorry, it's actually just an hello world example. So you actually, okay, I can run 33,000 requests per second, but I just realizing hello world. So every time I see some benchmark like this, I just say, it's not a real world application. I mean, when I write real world application, there's a bit more complexity. So a benchmark like this doesn't tell me anything about how my application will perform. And so to solve these two problems, I just made some benchmarks myself. And so I made a pointless benchmark too. So I just say, okay, let's serialize hello world just to see if I can have the same performance I saw on the Sonic repository. And yeah, it's actually true. I mean, Sonic is one of the frameworks that performs better when you just serialize an hello world object in JSON. But it's actually not the double performance compared to Falcon. It's just something less. Even if just on my machine, I had a lot of, I can make a lot of requests compared to the Sonic one, so I should contact the Sonic developer to send him my benchmark because they are quite better compared to him. But actually, let's make a realistic benchmark, okay? What a realistic benchmark can be. Let's say, for example, I made the REST API. I make REST API, so a simple test can be just, let's serialize 20 records from the database in JSON. And if you actually do that, you actually can see that Sonic not really performs better compared to the old stack. I mean, the performances are totally different just because you use a database inside the new stack. So, yeah, the point is, when you do benchmark, you should really think about what are you benchmarking, because there's some key facts about Sonic, because Sonic uses some libraries, for example, use a micro.json package compared to the other frameworks which uses the standard JSON implementation in Python, and use the Magic Stacks HTTP Tools library, which is a library written in Python and that actually performs really good on HTTP parsing. But they're faster independently of asyncIO. I mean, you're just comparing oranges to apples. I mean, a real test would be using the same library to do even the JSON serialization and the HTTP parsing of the request. And the other key facts, the other key facts I said before about asyncIO is the code simplicity, code explicitity, no? Because we said that threads are bad, and asyncIO is a way to have your code more explicit about all the I/O you do inside your application. So the principle is I want to know exactly where my application does I/O, because analyze how it how the stack work would be easier. But in practice, since you are doing a web application and you actually mostly dialogate with the database, you actually end up writing yield from on the wait on every line, because a snippet like this in the old stack will just transform in something where you just put a wait on every line. So it's not really dry. I feel quite like that when I see asynchronous web applications. And there's another key fact that you actually have to forget about thread locals. Now, thread locals are an easy way to don't have to transport some objects inside your application. For example, if you use Flask or other frameworks, you actually can just import some objects like the request, the response, and the session, and just use them wherever you want inside your application. But with the synchIO stack, since you cannot use this feature of Python, you actually just have to write request, response, and session everywhere inside your application. So you end up that you actually don't repeating yourself. You're repeating a lot in your code. Your code is just less dry. Okay, so your code is actually more complicated compared to the old stack. And also, I have another question about asyncIO. Are we actually reinventing the wheel? I mean, you remember Tornado? I mean, we had a lot of ways to do asynchronous things in web application in Python. We had Tornado, we have G-Event, which is the old implicit IO implementation. So with all these new stacks, so if you take some new frameworks on the scene, can you actually write a production ready app with these frameworks? Because I tried, but they're actually missing all the features I need in web applications. And also, are we just moving something problematic and taking out from one stack to another stack? Because before asyncIO in production, these two were your best friends. Nginx, USGI, and why you used these two actors to deploy your application? Because Nginx actually uses an event loop inside it, but it's written in pure C. So are we just taking the asynchronous part inside the application? And also, if I have to deploy a new application written in the synchIO stack, which tools I should use? Because still today, I'm not sure if I should put it behind Nginx, because actually an asynchronous application uses a server itself, which is asynchronous. But it's not so clear. Are we actually just moving the HTTP stack to the Python code? I don't know. That's a question. So probably you are thinking, you're saying you don't use asyncIO. Sure, I do. But I do just on the pieces of my code that actually need asynchronously on the IO stack, because I use it on the pieces that actually uses slow implementation on the IO, which is the principle on which the asynchronous IO stack was built. Okay, you have, for example, a network. You have to do a network request inside your web application. For example, this is a snippet for a social login. So I have a user that actually wants to use Facebook to log in into my application, and I have to send a request to Facebook and parse the results. Now, I don't know how much time this operation will require to my application to run. So this is a perfect way to use asynchronous I/O because it's a really slow application and it's... So I use on these peculiar things, but using it on everything about I/O in my application, I don't know, it's really a good thing. So, summing up, asyncIO is something awesome compared to the Node.js world because actually we just taken out all the callbacks flow, so you don't have to just write a lot of callbacks because it's implicit in your code. Your code is reentrant, so you just put an await to something that is I/O, and you don't have to write all the stack of callbacks. Python take care of the rest. UV loop is an amazing implementation of the event loop on Python because the performance are comparable to Go language. And with the latest release of Python, asyncIO seems to become pretty stable. There should be no more changes in the APIs. And also, this is also an awesome fact, PyPy started to support the all new languages stuff about asyncIO in the last release candidate. But, as I said before, concurrency doesn't mean things go faster. It means things are more concurrent. But if you just run some realistic benchmarks, you actually see that on database-driven web application, it doesn't really change the performance of your application. So there's no need to, I think there's no need to take asyncIO on everything in your web application. And also you should really avoid hype-driven development, and that's a typo. But anyway, when you do web application, please remember that the performance of your application really depends on your application code. The framework and the stack are just the smallest part when you really actually think about performance. And yeah, we see a lot of good stuff coming up, but I think yeah, we have to wait some time more to see actually something really usable in production regarding asyncIO. And so right now, today, I still see more cons compared to pros when I should turn an entire web application to the new async stack. But I hope maybe next year I will be here saying you why I use asynchronous I/O. But yeah, right now it's just something I think it takes too complication on your application compared to what you take in advantage. So thank you. Maybe we have time to discuss a bit if you have questions, considerations, critics.
Okay, thank you.